Okay, guys, we are back, and we are picking up with our transformations units. And specifically, we're going to start with translations. So there are four transformations: translation, rotation, reflection, and dilation. We're going to start here with translation. So let's get some general vocabulary out of the way, and then we'll dive right into it. A transformation is a function that moves or changes a figure in some way to produce a new image. Now, we have these terms called pre-image, image, and post-image. And all that means is that whatever image we're looking at, that might be the original or it might be after one change, there's something before it, a pre-image. And then we're going to do something to it and create a new image, a post-image. So these three terms kind of float a little bit, and I'll explain that a little bit more after I talk about prime notation. Prime notation is an indication that something was done. So prime, as you can see, looks like a single apostrophe or a single quote. So point P, we do something to it, and it becomes point P prime. So prime just means something was done. Double prime, two things were done. And at some point, those little tick marks can get a little messy. So we change to what looks like exponential notation. P3, P4, P5. So P5 would mean point P after five changes. Five things were done to it. What those things are doesn't really matter at the moment. Let's take 2 minutes and just tie this language together. And I'm going to do this. Let's say we have a point called A. Right? Let's just draw a little coordinate plane. And we have a point called A. And we're gonna move it. We're talking about translation. A translation is just a slide. So we're gonna move it to a new location. And we're gonna call that new one A prime. Rather than calling it B, we're gonna say that they're not two different points. It's the same, it's the original point, we just moved it. So we took a piece of paper on one part of our desk and we moved it to another part of the desk. And then maybe I move it again. And we'll call that a double prime. So I'm just taking this object, a point, a piece of paper, whatever, and I'm sliding it around my desk. So A becomes A prime, which becomes a double prime. And I can keep going. I can keep sliding this thing around my desk. Four, five. I can keep moving it around my desk. So if I move it 5 times, then the original point A just became point A5 because I did 5 things to it for a total of 6 places that it was. Think about that. Well, these words kind of just slide up and down that chain. So if I drag these words, maybe we started with the image and then we did something to it to get the post image. But now we're working on A prime, so we call that the image. And if we do something else to it, we get the post image A double prime. But the original, the one before A prime, the pre-image, was just A. And that can be confusing, but all we're doing is taking these three words and sliding them up and down this chain so that we can focus on 3 things at a time: the current image, the one before it, and the one that comes next. That's all. So if I said, look at A3, A triple prime, and we said focus on A triple prime, well, if that's the third change, there had to be something before it, the pre-image, A double prime. And if we do something new to it, we get A4, fourth change. That's our post image. Excuse me. So these words just slide up and down the chain so that we're always focusing on a current, a before, and an after. And we have this language to help us do that. Okay. So we have this other vocabulary. A composition is two or more transformations that are combined or done in a very specific order. So maybe we take our image, we slide it over, and then we spin it around. Or maybe we take our image, we flip it over, and then slide it somewhere. So two or more things in an order. And the definition of a rigid motion, something that we've talked about before. A rigid motion is anything that does not affect congruence. So a translation, a rotation, and a dilation, translation, rotation, reflection are rigid. They do not affect congruence. A dilation does. And that's something that we've talked about in the past. Well, we're going to start with translation. And a translation is nothing more than a slide. We're relocating the image. We're not changing its size. We're not changing the way it's facing, its orientation. We're just moving it from here to there. And we have two different ways of showing how we're moving it. The first is called a map or a rule. And the second is called a vector. Notice that they actually have the same information. Both of these have a +2 and a +4. So they're saying the same thing, it's just being written out two different ways. So let's take a quick look at this. Let's imagine again that we're on a coordinate plane. And we're going to take a point called A. And I'm going to move that point over 2 units and up 4 units. And it's still the same point. It's just in a new spot. So we're going to call it A prime. Well, look at that rule. That rule says take the original X and Y and do this. Take all the X's and add 2. So that moves it to the right. Take your Y value and add 4. That moves it up. So that's how we got from our A to our new location A prime. Now, if that was a triangle, we would do it 3 times. If it was a decagon, we would do it 10 times. We take every vertex of the image and we move it the exact same way, following the rule. The vector says the same thing. It's just a shorthand way of writing it. With a vector, we use these what looks like less than and greater than symbols, and we just put the X, the change in the X and the change in the Y. So the first value indicates the X direction, and then we have to give it a distance. So in this case, 2 in the positive direction. If it was negative, it would say, if it was going left, it would say negative. So the 2 and the 4, it's the same information, just written in a different format. And it's telling us exactly what to do. The only other thing with vectors is that we can name vectors. So in this example, our vector, it went from A, and the new point was A prime. So we would name the vector A prime, and the symbol for a vector is this little half arrow. If we had point B moves to point C, then the vector would be named BC with a half arrow. And in that case, the value of it would be some negative number because it went left, and some negative number because it went down. And we could literally just count it if we were on the coordinate plane. So let's just see how these get used a little bit. Now this video, I'm not going to run this video for you right now. You can look at it on your own time. Mashup Math has a YouTube channel, and they have some very good videos, especially for things that really help to be animated. not just writing numbers or an equation, but this idea of moving things around or rotating things around on the coordinate plane. They've done a really nice job of animating it. So I strongly suggest you go watch that video. Let's take a look at how to write these rules. So we can see our quadrilateral. We need to identify which is the original and which is after the change. Prime indicates change. So P is the original, P prime is the new, after the change. Q is the original, Q prime is after the translation. We're asked what rule was applied here. Write the rule for the translation. Well, we know every vertex has to move exactly the same way. So we don't have to do all four corners. We have to pick one corner. P moves to P prime. You want to use S? That's fine. S moves to S prime. It does not matter. I'm just going to pick one that I can clearly see. Sorry. P to P prime. So let's see. I'm going to go 1, 2, 3, 4 in the X direction. 1, 2, up 3 in the Y direction. So my vector is very simple. My vector is already 4, 3. Again, it's not in parentheses. It's not a point. It's telling us how things changed. It's in the less than and greater than symbol. As a map or a rule, we take the X and Y of the original point, any point, P, S, Q, R, it does not matter. And this is how we get to the new point. We take our X and add 4. We take our Y and add 3. Now, again, it's a rule because it works for all the points. If I'm going to work on point P, then at point P's X and Y is my starting place. If I'm going to work on Q, then point Q's X and Y. And then I add 4, add 3. So it's not for a specific point. It is for every point in the whole shape. Let's look at the second one. And I'm going to approach it the exact same way. Original to new. Original does not have a prime indicator. The new one does. So I need to know my direction. So for example, and I can choose any vertex, Q to Q prime. I go over. So this is to the right, 1. And then I'm going down. So down is -3. And I'm just counting. That makes my vector 1, -3. And as a map or a rule, I took my X and Y, moved it to a new location, following the rule. For the X's, we added 1, and for the Y's, we subtracted 3. And I do that for all 4 points, and that's how I get my new image, or my post image. Remember, those terms are a little bit interchangeable. In this example, we're given the rule. And in the first question, we're asked, what is the post image? So they gave us J. They asked for the post image, which means they're looking for J prime. So J becomes J prime, and that's the rule. The rule says add 6 to the X's and subtract 3 from the Y's. So 6 plus 4 is 10. 5 minus 3 is 2. And that's where J prime is. In the second example, note, be careful with this one. This one works a little bit differently. It's actually backwards. What is the pre-image? They're giving us R prime. Remember, R becomes R prime. So we know R prime is at 0, -5. We're being asked what was the original point. But again, we were told the rule. We took the x, added 6, and we ended at 0. So x is -6. We took, sorry. So if for wherever r was, the original x, the rule said add 6 to get to prime, which is at 0. For the y's, the original y, the rule says subtract 3 to get to prime. Well, if we add 3 to both sides, we get y equals -2. So r, the original point, was -6, -2. And you could double check that. Apply the rule. Add 6 and subtract 3. Make sure that you end up at prime. The arithmetic that we're doing is extremely simple. We're adding, subtracting. We do x's with x's and y's with y's. This is just that mental thought process of, here's the rule. If I start here, where do I land? Or, here's the rule. I landed here, where did I start? So we're just doing the opposite. Subtracting 6, adding 3. We're doing the opposite to figure out where we started. In this question, we're asked to apply a translation to a triangle, and we are given the vector. So we should always graph the original. In fact, it says graph the triangle and its image, so we're going to have two triangles. And it tells us to be careful of the scale on the coordinate plane. So if you look at this coordinate plane, it's counting by 2s. We do have to be very careful here. So let's graph our original and see where we end up. 1, 2, so 1, 2 is point A. B is at 5, 1, and C is at 5, 4. C is at 5, 4. And that's our original triangle. Now we're going to apply the vector. So let me just move over here. I'll write out the math for it, and then we'll do it. A is at 1, 2. B is at 5, 1. And C is at 5, 4. That vector, think about what that says. It says from the x value -2 and from the y value -4. Well, that's going to give us a prime. 1 minus 2 is -1, and 2 minus 4 is -2. So a prime is at -1, -2. And we label it a prime. And we're going to do the same thing for point B, following the same vector or the same rule. Subtract 2 from the x's, subtract 4 from the y's. That makes point B prime. 5 minus 2 is 3. 1 minus 4 is -3. So I can come over here, 3, -3. And that's my B prime. And I'm going to do the same thing for C. That's why it's a rule, so that we can follow it for all the points of the image. So we get 3, 0, 3, 0, and that's C prime. So there's our new triangle. They are congruent. It is just slid over and down. Triangle A, B, C was translated to become triangle A prime, B prime, C prime. So we can apply our vector notation. Okay. Let's get a little practice with our translations, doing some compositions, which again, composition just means more than one step done in order, so we can see how it changes at each step. And then we'll move into some of our other transformations.